Let's discuss today the solubility product, the KSP. KSP is applied to saturated solutions. This is saturated solution of AgCl of sparingly soluble salts. This is a silver chloride salt which has very low solubility in water. And here we can see the general equation to calculate KSP. KSP equals multiplication of the concentration of the soluble ions. So we can make use of KSP either to find the KSP value from the concentrations of the ions or soluble ions, or calculate the solubility of the salt from the value of KSP. And the third use is to find the concentration of one ion from the value of the KSP and the concentration of the other ion and the solution. Here is the first application for KSP. In this example, we have given the solubility of AgBr, the salt AgBr, and in the unit of gram per 100 milliliter at certain temperature. And we are requested to find the value of KSP. So first of all, we have to convert the unit from gram per 100 milliliter into mole per liter. This can be happen in two steps. This is the first step where we have converted the mole into liter, and this is the second one where we have converted the gram into mole by dividing this amount on the formula mass of the salt. This value represents the concentration of Ag plus ions, the silver ions, and the bromide as well. Okay, now by applying this value into the equation of KSP, we can get the value of KSP. Your assignment is to tell the KSP unit here. What is the unit of KSP in this example? Please answer it on your accounts in Google Classroom. Thanks a lot. This is another example of KSP. It's almost same as the one before. We are requested here to find if the salt is going to precipitate or not. So we are going to follow the same steps we did before, but here we are going to compare the result, the value of the multiplication of the solubility of the salt ions with the value of KSP at the same temperature. And since the value is more than KSP value, then the precipitation will occur. This is another example of KSP. My advice is to try it yourself, to try to solve it yourself without seeing the solution, of course. Now let's skip to the next one. Also, you can try to solve this one without seeing the solution. Here is another example. Cation effect the addition of a soluble compound with a mutual ion, like the ammonium here, ammonium ion, will decrease the solubility of a precipitate. This is the mutual ion. So common ion effect reduces the solubility. If we have common ions, this will reduce the solubility of the salts. This is another example. AgCl in general has a very low solubility in water, so it's partially dissociated. By the addition of AgNO3, silver nitrate will liberate or dissociate it to produce silver ion. Silver ion here is common with the first reaction, so this will decrease the solubility. See here, increase the amount of AgCl. So as per Le Chatelet principle, this will revert the reaction above and will prevent it from dissociation. So this will reduce the solubility of the salt, of silver chloride salt. So common ion reduces the solubility. Thanks. Here is an example for common ion effects. So I want you to do your best trying to solve it without going to the solution directly. I have divided the solution into 3 steps. This is the first one, the second, the third. But I want you to do your best to solve it yourself. Thanks.